All right, hello everyone. Today we are going to discuss the topic of Shiny modules. This is chapter 19 of the Mastering Shiny book. Switch to the slides. So in the previous chapter, we discussed functions and we discussed that functions could be used individually on either the server side or the client side for various use cases. If the server code relies on a specific structure in UI, then we should use modules because modules would capture both the UI side as well as the server side. Here's one example in the book chapter that talks about modules where someone had this complicated application where we have different components, for example, the settings viewer for the session and settings viewer for the cluster. Uh, this is repeated. So the same functionality is repeated twice. Similarly, we have the select variables function that is used for table as well as for plot. So if you have the code that is reusable and it is reused both for the UI as well as for server, modules are very useful. So uh, here are some benefits of modules. Uh, the first benefit is that we can avoid namespace collisions. This means that since all components, inputs and outputs in a Shiny app require an ID, if we have ID, the same ID for different components, Shiny app is going to throw an error. And that means that there is a collision within this namespace in which the components are created. So what we want is we want to avoid these collisions, and especially when you are creating a lot of components using something like per or lapply in R, you may get into creating same ID for multiple components. So we want to avoid that. Uh, Modules also allow encapsulation for distinct app components. This means that we have different components for the app. As we were discussing before the recording, there could be a component for connecting with a database, a component that cleans the data, and all of those could be put in separate R files and then called in the main app.r file that helps us put them into distinct components. It also facilitates collaboration because if multiple people are working on the same app, multiple people could divide the work and the type of functions that they want and put them into separate modules. Modules work similar to functions because they are essentially functions. They help you break your big complex app into small parts, make Shiny code more readable because we are not putting everything in a single app.r file. It's also easy to debug where exactly the error happens in a Shiny app, if it does happen, and it makes Shiny components reusable. So if you have, for example, just like a function, if you have something that mimics a page, like in a tab for Shiny app, where the only thing that differs is the data, you can create a module for that tab and then you reuse it multiple times on different tabs. It also opens the possibility to apply a unit testing for testing individual components of your app. So in the previous example that we saw, this is when modules were implemented, and we see blue and yellow components. So blue components, as I said before, were about settings, the viewer settings. They were either in the session part of the app or for the high performance clusters part of the app. And in this example, they used the same module twice. Similarly, the yellow part is where variables are selected, and based on those variables, tables and plots are created. And so that module is also reused twice, once for the data part and once for the results part. So here's an example of a simple Shiny app where we have not yet implemented modules. Let's switch to Posit Cloud, and we have that Shiny app here. So we have two inputs, select input and numeric input, and one plot output. This plot output will contain a histogram as is shown here. This histogram uses the input bins from the numeric input and the input var from the select input. If we run this app, it probably doesn't run within the same window. I need to change the setting here. Now in the viewer pane, now if you look at it, so here is our app where we have a variable to select. For example, I select displacement and number of bins, and that would create this plot. Changing that changes uh, the plot as well. Now, to implement the modules in this app, although this app is simple, it does not necessarily require to put it into distinct components in a module, but this is a nice example to do that so that we understand how modules work. So I'm going to comment out this part and refresh the session. And now we have separated the UI and the server parts into different functions, which are part of a single module. So in this case, for histogram UI, this is the name that the book uses for the UI part of the app. Again, it has the same components as we actually had in the app. Select input, numeric input, and plot output. These are the same component here. And we also have the server part, which also has the exact same code. There's no difference. The only difference that you would notice here is that I have this line ns that is an assigned value based on this function ns. If you look at the ns function documentation, it's part of Shiny. So let me first load Shiny again. So ns is a function that creates namespace IDs out of bare IDs, which means that if I take the ns function here in the console and I type an ID, for example, my ID, and I also provide an ID for the select input, which in this case is var. This will create a combined ID. So this is essentially what this is saying, that ns function creates namespace IDs out of bare IDs. So now the var ID, which is the bare ID, is now namespaced with this my ID namespace. The advantage of this is that if I want to reuse this histogram UI anywhere else in my app, I don't need to change these IDs, the bare IDs. These will remain the same. The only thing that will change is this ID. In the book, it's ns function, the capital NS is directly used. If I switch to the book chapter, you'll see that it is directly used this way. But this is slightly more amount of code that you need to write, more keystrokes. So this is a nice shortcut that the snippet from our studio also suggests. So with ns, it is essentially creating this as a function. So if I say ns, the small ns, and it is ns of my ID, then looking at the result of ns, it shows us that it is essentially a function. When you provide an ID, it will namespace that ID. So that's the same thing, but used in a different way. Histogram server part has the same exact code. We don't need to use ns for histogram server for this example, because the ID here, when provided to this function module server, this ID will automatically namespace our bare IDs for us. So in this case, the bear ID was var. Because we are using input var, using the ID here within module server means that it takes care of the namespace. So we don't have to repeat that here. But if you do create a new component, for example, in a render UI, and you are creating a select input, for example, in render UI, in that case, you need to provide NS. But in this book chapter, that example is not discussed. So essentially, we have the same app with histogram UI and histogram server. How do we use these components? How do we use this module? We can now use this module and also test it if we put it inside a function, and then we can run that function. So here is the reduced code, which you can imagine would go into the app.r file. So we have fluid page, which has histogram UI UI part. We provided with a new ID. So now instead of my ID, the example I used before, we are providing the ID hist1. So var will be namespace with hist1 as hist1-var. And then we use the exact same ID in the server for the server component of the module. The remaining code is as we use in the Shiny app. We wrap this inside a function for experimentation and testing. For experimentation, because we want to see if the module is working, and we can do testing by adding more things to this app, this small app, or whatever we want. So once we provide that and we then run it, because this function has no arguments, we can see that the exact same app is created. By change this back to displacement, increase the number of bins, we see we have a working app. In these slides, there is also an example of the Shiny app, which is shown in the Shiny Live contest. So if you want to take a look and interact with the app, this is also nice. There's another example where the module's isolation is used. So in this example, it's still continuing from the previous example, output out will never get updated because there is no input bins. So this is a slight modification of our app. So we are using histogram UI and histogram server. And we are also adding to it a text output. And the text output is created here in the server, where we say render text, this part. So the number of bins we are providing as input bins. Now remember input bins, if I switch back to the R script, the bins part in the UI is this numeric input. So this ID bins is for the numeric input. But this ID is namespaced with hist1. So in your main app, the ID will be hist1-bins. If you try to use the bins here, this won't work because this does not exist for this app. What exists is input hist1-bins. In a module, it's taken care of, but outside of the module, it's not. So if you want to create an output like this should also be part of the module. And here are some conventions of how to name these modules and how to use them. So in the example that I provided here, in this example, I am using the exact same R script to show the UI and server components of the module, and also the histogram app and testing it. We can use this in our workflow, but this should be named as a module file. So in this example, I would name it as histogram.r. And this histogram.r file should be within the R folder. And then we have to source it. We have to source it in our main app.r in order to uh, use this. This is also an example of the main app.r, but this is done here just to test it. In our actual main app.r or app.r actually, we'll have something like this, but obviously we'll have other components of the app as well. The other convention is about naming. This is how the UI component is named UI, and that's because uh, in this case we have input and output. According to the author, if you want to be more specific, you can use input and output. Uh, and for server, again, we use the same prefix and we use the server at the end. And histogram app is again using the same prefix that creates a complete app, and this is just for us, and we put that in the same module for testing. While we are actually using the app, it would probably be better, actually it would be best to comment this part out because we don't want to run this as our main app.r is running. In my personal opinion, and based on the another book, Engineering Production Great Shiny Apps, another good convention for naming modules is to use mod, which tells us that this R file that we have contains a module. So we have mod underscore, for this example, it would be mod underscore histogram underscore UI. Similarly, mod underscore histogram underscore server. This tells us that we have UI and server components, and these are actually part of a module when we look at the code inside app.r. Exercise 1 says, why is it good practice to put a module in its own file in the R directory? What do you need to do to make sure it's loaded by your Shiny app? So one good practice, one reason why it's a good practice is that we can, if we want, turn this into an R package. So our app will be residing inside an R packet and will be easier to use for other developers. And we need to source this. With the current setup that I showed, where we have an R folder and that contains our module R files, and we have an app.r folder which is outside of the, sorry, not app.r folder, the app.r file, which is outside of the R folder. It's in the root of your main app directory. There, in something like global.r, you need to source your all your modules. So this is one function that could help sourcing that. In frameworks like Golem, you don't need to do that because it takes care of that automatically. So once you run your app, it would automatically source all the R files in the R folder. Exercise 2 is the following module UI includes a critical mistake. What is it and why will it cause problems? So in this case, the critical mistake is that since we are creating a UI for our module, our bare IDs should be namespaced. In this case, they're not. So on the next page, we'll see that they are namespaced properly, and now it's good. Exercise 3, the following module generates a new random number every time you click go. So in this case, we have an action button and text output, and we are creating a random number using event reactive and then showing that in the val in the output val. So in this case, we have random UI and random server. So these are already parts of our module. And if we want to reuse it, the question says create an app that displays 4 copies of this module on a single page. Verify that each module is independent. So in this case, if we run this with multiple instances of random UI, we are reusing the module, but in each case, we just provide a different ID. So the main IDs for the inputs and outputs, they remain the same. We don't need to change them, but they're namespaced according to these IDs. So if we run that, it will create the app for us, and it will be working because we have properly namespaced the IDs. So this is the first one that generates this number. And if I change it, every time it generates a random number. The third part of the exercise 3 says, how would you change the return value of random UI to make the display more attractive? So this is optional for the purpose of this chapter. In this case, they went from this random UI code to using BSLib value box, and they also use the page fluid layout. So within page fluid layout, it's just like fluid page in Shiny, but it's part of DSLib. And layout column wrap is a function that will lay out all the components inside it and will wrap it based on the screen size. So if you have a bigger screen, everything will be in a single row. If you have a smaller screen, then they will be rearranged depending on the screen size. Some of the options that they use here is to provide a half width, which means that on one row we need to have two components, and they also provide an optional height here, and then the same random UI module is reused here. So we use that and then run our Shiny app. We'll see the exact same app as before, but this time the UI will look better. So here we go. We have 4 buttons for Go. Right click on this, it generates this number, and so on.
Yeah, and this is like the recommended way of doing it by Shiny, or is just in the book?
This is just in the slide. It's not even in the book, this example. And this is just part of exercise 3.
Yeah, cool.
But now it is recommended if you go to the layout article on Shiny app for R. Now you'll see throughout the article they use BSLib functions.
Yeah, sure.
Now the third section, I think, in the chapter is inputs and outputs, and the slides here only cover up to this section. So today we'll wrap up with this section, and in the next week we'll discuss the remaining chapter. So there are several examples within this section. Adding arguments to the model UI gives greater control over module appearance, which means that in addition to the ID argument in the module UI function, you can provide more argument. And connecting modules together requires you to be explicit about inputs and outputs of the module server. This means that since anything that is outside the module, if you try to refer, for example, input bins in our previous example outside of the module, it will not work because bins is namespaced. So how do we communicate data? How do we communicate from one module to another? So in order to have this communication between modules, we need to pass the data from one to another. So that goes as an argument to the function for the module server. So it's much easier to understand and allows you to build substantially more complex apps if you if you connect modules together. But it's uh, a little difficult to start with because you need to think about how to get the data outside of one module and then pass it to the other. So the second example here is app number 2. And let me check, it's the same app. That's the dataset input app. So in this case, I'm loading Shiny a package. Let me restart. and we have the dataset input as our module UI. And this time we not only have the ID as the argument, but also have the filter argument, which the default value is where the default value is null. Again, I use ns to namespace the IDs. In this case, we have a single select input. And so I namespace it with ns function, and the bearer ID is dataset. What we're doing here is we are getting the names of the default datasets in R, and then if we provide a filter, the filter could be if it is a data frame or if it is a matrix, because the datasets in the package datasets in R contain datasets which are either data frame format or matrix format. So if we provide filter, then this part will run and it will grab either the names of data frame type datasets or the names of matrix type datasets. If you don't provide that, it will just provide the names of everything in the package datasets, and we then pass that as a choices to names. On the module server side, we need a methodology to grab that data set. So we have the function ID. In this example, we are only using a single argument ID. And we have this line module server, as we saw before, which has ID, function, input, output, session. This is much like the server function and the main server function in app.r. And similar to the example we saw before. And this is new for this particular dataset server, for this module server. We are using the get function to get the input dataset, the dataset that is selected here, the name of it, based on the package datasets. But notice something here. Remember that in a function in R, the last thing that you have is returned. So this is returned to us, which means that we are getting the data set and then we are returning it, but not only returning it as a bare data set value, but we are making it a reactive value. And remember, we are doing this because in this case, we are not displaying the data in any way. We are not using a plot output or something. We are returning the data. And whenever you want to return data with a module, you need to use a reactive. So now that we have UI and server parts of the module ready, we can put that in an experiment, and we can create a small app and test it. So with a small app, we create a fluid page, and within that, we use our dataset input module, which is UI part of the module. We give it an ID dataset, and we provide it a filter equals filter. In this example, the filter is null, and the default value is null, and the server part uses the dataset server. But because dataset server, this thing, returns a reactive dataset, we can assign it a value. We can now create this data, which is coming from the dataset server. And this data would be reactive. And then within render table in this small app, we look at the head of data. Since data is reactive, we need to use these brackets. So I'm testing here the dataset app with filter equals is.data.frame and filter equals is.matrix. So let's run this app. So first I'll run it with the data frame filter. And now all the dataset names here are for those that are data frames. So if I change it, in all cases, we'll see data frames. And if I rerun it, and this time with matrix, now all the names we have here, these are for matrices. So you can imagine if you have this module and you want to use it twice, you can use it this way. But the main point of this section is to notice that whenever we want to return data or pass data from one module to another or to the main part of the app, we need to return it as a reactive. In this example, we use it here to create a table. In this case, extracting a numeric variable, we have more example. I think it's for the same app, create a control that allows the user to select variables of specified type from a given reactive data set. So in our example app that we made, we are not only looking at, we were looking at just the dataset name, but we can further build the app to select a particular variable from a dataset. So this is an additional input where we have select input that is going to select a variable. And initially we use null for the choices because at this point we don't know what are the choices because we don't know what data frame our user will select. So we put this in a function to make it a module. So this is the select var input, which is part of the module, and this is the UI part of the module. We further create a function and also create the select var server, the server part of the module to use this. I guess I have that example here as well. Yeah. So let me restart first. So now we have two modules. The first module is the same as before, as we saw here. It's the same module, the dataset input. The second module is the select var module that we just saw in the slides. The select var module, the UI part only has a select input with no or null choices in the beginning because we want to update these choices based on what data frame that the user selects. To do that, we are going to use the find vars function that will take in our data set, a data frame or a matrix, and the filter. This filter is different, by the way. In this case, we are going to get the names of the data, and for each data set, we are going to apply uh, uh, the this function filter. If you look at just to remind how we apply works, the reapply has these parts. The first argument is list, the second is the function we want to use, and the third is the fun.value. So this thing would return true or false. Sorry, this part would return true or false. And then based on the true or false, we are going to select the names of the data. So we essentially want to select those columns or variables from the data that match a certain filter. So we use that in the server part of the module. So the first part is the same as for any server part of the module. Then we start with the observe event. And this time, notice that we are using multiple arguments in our select var server, the server part of the module. In the previous example, we saw only the UI used two arguments. In this case, we have multiple arguments for server part as well. So we provided with the data, and remember this data is coming from the data set input, this data set module. So once that data set is selected by the user, we then provide it to our select var server module. And once that is provided, the choices in the select input will be updated depending on what data frame or what matrix is provided. To provide those choices, we use find vars as we have seen above. And once the choices are updated, we then return the data based on the variable that the person has selected. this part is going to show only those variable names which belong to the selected data frame. And then this part is going to return that variable from that data frame. So both data frame and variable is selected by user, and then it is returned from this module. So here is our small app that tests this. Uh, Here in this case, the default argument we are using is that the variable we want to select is numeric variable. So we first put our dataset input module, then we put the select var input module, and then we just return the text output. On the server side, we get the dataset server to return a reactive data, which is either a data frame or matrix, as we've discussed before, and we name it data. Once we have data, we then provide that as an input to the select var server, the select var module, and then we have that data provided here, and the filter is is.numeric, as we see in this small example. And then we return it, and then we create render the print of that variable that we have in this output. So I'm going to run this after restarting. And now we have the data set as well as the variable compared to the previous app where we only had the data set selected. So we have this returned, but you can see how neatly we went from data extracted from this module and then input to the second module, and then finally we rendered it on the app. And all of these modules, in this example, because I'm working with a single RStudio project, I put everything in a single file, but all of these modules should actually go in a separate R folder in your main app directory. Any questions, Ahmed?
No, that was very, very clear. I think this is the most interesting chapter because really it introduces the way of thinking of how complex you could go into the apps into building the building blocks of your app, and how you could connect modules together in creating this kind of a structured app, but it's very composable, so you could use it in multiple apps at the same time. And as well as if you have this kind of mindset of building everything as a module, we will and create this packaging like package from the module itself. I think this is really would be very useful for you in the long term when you of course you will make it like a collaboration environment when you want to cooperate in you could see a package or a package app as a feature that you get delivered into the main application, and everyone is going to build its the feature that or the requirement that is by the business that required by the business, and you could contribute to the open source or to contribute to your repository uh, by doing that. So it's really actually it's very interesting that uh, the power of modules is really like, and I think this chapter is doing this, is like gaining all the knowledge that we have explored in the first chapter, from the first chapter till now, and combine it in a practical way, how you could build apps that is reusable and composable and very robust, and as well as how you could think of modules as a way of thinking, not just um, um, a feature that you could use. No, it's actually like recommending you to always think that way, because this is how production ready Shiny app is being delivered to a business people. So that's why he is recommending that way of creating apps. So yeah, that's my just small tips
Yeah,
for
thanks.
yeah,
That's it all affirms that yes, using modules makes things easier and often clean
yeah,
to work
yeah.
with. Thank you. Um, so there are a few tips in the chapter as well. For example, one tip says validate if reactive. So if we have a reactive component that we are returning from our module server, it's always, or sorry, when we are getting it from the as an input in a module, it is better to validate if that thing that we are inputting is a reactive or not, because then we don't get errors that are weird for the user. So here's an example. In this select var server that we saw before, we have ID data filter equals is dot pneumatic. So data is reactive, we know that, but we can also put this statement stop if not is dot reactive data to check if it is reactive or not, because later when we use data, we use it assuming that it is going to be a reactive, but you may forget while you're working with the other module, or your collaborator may forget that you need to return a reactive, not just a bare bones data frame. So in that case, uh, you expect that it should be a reactive data frame. So it's better to test this, because if you have this line, then it tells you that you were expecting a reactive and you didn't get it. But if you don't have this line, it will say data not found, and it would be weird because you may be using the word data as the argument name in many different modules, and you wouldn't know where exactly is that happening. So it is very useful to use this line. And similarly, we use it for non-reactives as well by just putting an exclamation here. In this case, filter is non-reactive. Another tip is to validate the input of each argument. So in addition to using this, we are also uh, we are also using is dot data frame. So previously we were just saying stop if not, is dot reactive, if it was reactive or not. In this case, we are inside a function, not a module or more component of a module. We are just checking if our type is what we expect. So this is also nice to test this and easier to debug. App number 3 is where we are using modules consolidation. Um, so with modules consolidation, we are still working with the same app as before, and we are adding one more component to it. So we have the first module data set, the second module select var as before, and we now have this third module that's going to combine data and the select var modules in a single module. So we have data set input and we have select var input. Both module, the UI parts of the module are going to the UI part of this new module. Similarly, the dataset server and the select var server, they go into this new server part of this new module. This module is called as select data. So you can imagine where you have different pages of your Shiny app, and in each case, you allow people to do exactly what we saw in the running Shiny app, where you have a data frame or a matrix that the user selects, and also then selects the variable out of it. So you may want to reuse this, or it is also nice just to put this in a single module, even if you're using it just once, because it is easier to debug and it's also easier to put this code aside in your R file and not litter your app.r file. So we have the exact same code as we saw in the previous example, but now nicely put in this module. And then when we experiment our app, we again use filter is not numeric. And this time we are now able to change the layout of our app because we have bundled together the two modules above. And in this case, in the sidebar panel, we have the UI part of the module. In the main panel, we return the result of the selected variable. In the server part, we have, again, that combined modules in a single module in the select data module, where we provided with the builder, which in this example is .numeric. And similarly as before, we uh, render the print of the selected variable. So let's run this. And we see we have the exact same app as before, but this time we have a nice sidebar module. Another tip is module functions must be flexible enough to be used in multiple places. As I said, you can use them in multiple tabs, simple enough that they can easily be understood. Expect that you'll have to do it wrong quite a few times before you get it right. So this is mostly trial and error, especially when you are just starting. App number 4 is bind and histogram. This is again, if I'm correct, using the same app as before, but adding the histogram visualization to it. So if we switch to that, we have the dataset input, and then select var, and then the histogram output. In this case, we did not combine them into the select data module, but we kept them as separate modules, and we added a new module which is using some of the inputs and creating the output of the plot output. So we have the bins as the input, and the output is going to be a histogram. So in this case, we check if the argument X is reactive or not. And we also check if the title is reactive or not. So this is from one of the previous tips in the chapter, where the title is also reactive because it will change depending on what variable the user has selected. And it will also change depending on what number of bins the user has selected. X here acts as the variable itself, which we will get from the select var module. So we are passing data from one module to another. And this is the regular histogram plot in the base R plotting system. The only thing to notice here is that we're using the input bins, and we are basically pasting the title histogram. That's why this is reactive with the number of bits. That is why we kept the title as reactive instead of just title equals to histogram, because we want to be able to use it, update it within our plot. And now we put that in our small testing app here, where we put the dataset input module inside the sidebar panel and also the variable selector. And in the main panel, we have a histogram output. On the server side, we use the dataset server, select var server that uses the data from the previous module, and then the histogram server that uses X, which is the variable that select var server returns. So we can see the communication that happens between multiple modules. So in this case, we have selected air quality, the variable ozone is selected, and the number of bins are selected for creating the plot. If I change the variable to wind, in this case, we see the title as well, histogram 10, and I'm going to change this. We see that the title is also updated. Another tip is it will give two separate elements in UI depending on the same server module. So instead of using just that histogram module that we saw before, so the name or the prefix of the module is histogram, you can give it more parts. You can separate the UI part. If you look at the UI part once again, the UI part has two parts: numeric input and the plot output, right? So we can separate them here. We have numeric input and we have plot output. So this part of the code remains the same, but we have separated them into two parts of UI. And both need to use the same ID, as we'll see on the next page. So histogram output bins, this is part of the UI of our module. This is using the hist ID. Similarly, histogram output plot, this is also using the same ID, and that's because this ID is going to namespace the IDs provided inside these two parts of the UI. So bins and hist both will be namespaced using the hist ID. So we can, if we have complicated UI, we can separate them into different parts, provided we use the same ID if we want to refer to the same instance of our module. Another tip is multiple output. To solve this problem, you just need to wrap all your inputs in a list, which means that when we are returning data from a module, you need to wrap that data inside a list. So in this example, we want to not only return the variable, but we also want to return the selected variable. So this input var is what variable we have selected. And this is the actual value of that variable. So name and value both are bundled in this list, and this is what we are returning from our server part of the module. And then we can reuse it as shown here, where we, within the histogram server, because it requires both the value of the variable as well as the name of the variable, so that we can nicely name the title of the histogram. We then use that list X that is coming out of select bar server. If we run that app, we'll, I think it's shown here. Yeah, I'll first show that and then go back because there's another tip there. So here we have the data set that we pick, the variable that we can pick, and the number of bins. So now instead of saying histogram, we have the variable name as well. That's the advantage of putting or wrapping the two outputs in a list. If you don't want to use list, you can also use the zealot package. With the zealot package, because this module is returning two values, you can use this syntax. So this is the same as before, but we are now using this pipe operator to name two values. And then we can use those value and name. I think we are out of time. So we'll discuss these exercises for the input and output section on next week. And we'll then continue discussing the remaining sections of the chapter.
Yeah, sure, sure. That's why, and what this was a very like informative